Hi friends, good morning. Myself Mr. Sanap, lecturer in Mechanical Engineering Department of Wagh Polytechnic, Nashik. Friends, today we are going to discuss about the annealing, then types of annealing, then what are the different effects of annealing on the properties of steels. Then we will see the purpose or objective of annealing and application of annealing. So friends, annealing is one of the most important heat treatment operations. The process of heating a metal which is in a metastable or distorted structure state to a temperature which will remove the instability or distortion, and then cooling so that the room temperature structure is stable or stain free is called as annealing. So in next slide we will see what is the objective of annealing. So there are different purposes of annealing, or we can say objective. The first one, inducing a completely stable structure, then refining and homogenizing the structure, reducing the hardness of the metal, then to improve the machinability of the metal, then to improve cold working, then characteristics for facilitating further cold work, then producing desired microstructure of any material, then to remove the residual stresses if any, then it is also used to removing the gases and improving mechanical, physical, electrical and magnetic properties. Then there are four types of annealing, that is conventional or full annealing, then isothermal annealing, spheroidizing annealing and process annealing. So friends, we will see one by one. The first, that is the, we can say, conventional or full annealing. So full annealing implies annealing a ferrous alloy by austenizing and then cooling slowly through the transformation range. The austenizing temperature and hypoelectric steel is usually between 723 degrees Celsius and 910 degrees Celsius, and for hyperelectric steel austenizing temperature between 723 degrees Celsius to 1130 degrees Celsius. Full annealing, this involves heating steel to proper annealing in the austenitic zone, then holding steel object at that temperature for a definite period of time depending upon the thickness or diameter of the component. So it is near about 2.5 to 3 minutes per thickness, so that it becomes completely austenitic. After that, the steel object cools very slowly through the transformation range, preferably in the furnace, till object acquires low temperature. Then slow cooling associated with full annealing enables the austenite to decompose at low degrees of supercooling so as to form a perlite plus ferrite structure in hypoelectric steel, a perlite plus cementite structure in hyperelectric steel. Full annealing, it helps to refine grain structure, then remove the strains, induce softness in the metal, then to improve the machinability of that particular component, then improve the formability and improve electric as well as magnetic properties. Then second type of annealing, that is the isothermal annealing. In this process, the components are slightly fast cooled for usual austenizing. Temperature of conventional annealing to constant temperature below A1 held at this temperature for sufficient period for the completion of transformation and cooled to room temperature in a year. Isothermal annealing has a distinct advantage over conventional annealing, which are as below. The first, that is, it reduces the annealing time, especially for alloy steel. Then transformation occurs at the same time throughout the cross section. It shows improved machinability, improved surface finish after machining, and less warping during subsequent hardening processes. So isothermal annealing is cheaply used for medium carbon, high carbon, and some of alloy steel to improve their machinability. The increased machinability is due to formation of spheroidized structure. Then another third type of annealing, that is spheroidizing annealing. Spheroidizing annealing involves subjecting steel to a selected temperature cycle, usually within or near the transformation range, in order to produce a spheroidal or globular form of carbide in steel. There are some benefits of this spheroidizing annealing. The first one, it improves the machinability of any component, then facilitate a subsequent cold working operation to obtain a desired structure for subsequent heat treatment, then softness to steels, improves surface finish during machining, and it prevents cracking of steel during cold forming operations. So these are the some benefits, or we can say advantage, of this spheroidizing annealing. So here a spheroidized steel has a lower hardness and tensile strength and a correspondingly higher relative elongation and reduction of area than steel subjected to normal annealing. Spheroidizing is extensively used for high carbon steel to transfer laminar perlitic cementite into spheroidal type. Cementite spheroids are embedded in a mixture of ferrite. The spheroidized condition is produced by one of the following methods: heating steel and then its prolonged holding at a temperature just below lower critical line, that is between 650 degrees Celsius to 750 degrees Celsius. Heating and cooling steel alternately between temperature that are just above and just below the lower critical line. Heating to a temperature above the lower critical line, that is between 730 degrees Celsius to 770 degrees Celsius, with subsequent holding at this temperature followed by slow cooling at a rate of 25 degrees Celsius to 30 degrees Celsius per hour to 600 degrees Celsius. Then fourth and last type of annealing, that is the process annealing. So process annealing is a subcritical annealing and is applied to remove the effects of the cold work to soften and permit further cold work, as in sheet and wire industries. Ferrous alloys are heated to a temperature close to but below the lower limit of transformation range, that is between 550 degrees Celsius to 650 degrees Celsius, are held at that temperature and then cooled in a year in order to soften the alloy for further cold working, as in wire drawing. So process annealing associates with it only partial recrystallization of the distorted ferrite, and since mild steel contains only a small volume of strained perlite, a high degree of softening is induced. So process annealing does not involve any phase change, and the constitutes ferrite and cementite remain present in the structure throughout the process. So process annealing generally carried out in either batch type or continuous furnace, usually with an inert atmosphere of burnt coal gas. Cast iron annealing pots may be used with their lids being glued on with them. Then there are some effects of annealing on the properties of steel. The first one, it softens the steel, then it improves the ductility of steel, it enhances machinability, it relieves internal stresses, it improves electrical and magnetic properties, and refines the grain structure. Then there are some applications of annealing. It is used uh, in bolt shafts, then lock nuts, then end of metal stamp set, stainless steel grid cutting saw blades, then tungsten rods band annealing on titanium fasteners, brazing wire, a copper wire connector, that is cream, steel wire for a medical application, then stainless steel caps for a dental application, then thread ring gauges blocks, the end of hydraulic motor shaft prior to machining, then aluminum fuel tank feed neck for bending, then satellite tips on saw blades, continuous annealing of copper wire, hole cut out on stainless steel tube prior to extrusion, and the end of steel wire on a oval wire mesh. Thank you.